So today our topic is projectile motion. So you guys know when we throw something to air, to our atmosphere, it will follows a path like this. So what is the reason for this path? And the reason is this: once we are throwing this, we are applying a velocity or we are giving a velocity in this particular direction. And this velocity will have two components, one horizontal component and other vertical component. And this vertical component will be affected by gravitational force or acceleration due to gravity. So once we set this to motion, we are not applying any force, then the vertical component will be reduced by the acceleration due to gravity. We can draw the vertical component and horizontal component like this. The horizontal component will remain same because there is no other force in the direction of horizontal component of the velocity. So we are neglecting all other forces such as friction. But in each step, the vertical component will start to decrease because of the acceleration due to gravity, which is acting in the downward direction. So once it reaches the maximum height, this is the maximum height for the projectile, then when it falls down, then we can see that the vertical component will changes the direction in the downward direction. So the horizontal component still remains the same. There is no change for the direction of the horizontal component also. Once the projectile hits the ground, then the horizontal component will be like this and the vertical component will be like this. So whenever the object is falling, the vertical component will increase because of the acceleration due to gravity in the downward direction. So this is what's happening in the projectile. So you can imagine like you are kicking a ball from the top of a mountain, and here also you can see that it will follow a path like this. So this is known as projectile motion. So if you guys look, you guys can see the path followed by the projectile is look like this. So for this shape, in mathematics we say a parabola. A parabola, maybe you guys are familiar with the parabola. Parabola will be drawn like this. It has to be fast to the origin. So the path followed by the projectile is look like a parabola, and we call it as a parabolic path. And this path followed by a projectile is known as trajectory. Trajectory of the projectile. Trajectory of the projectile. So this is the basic things about projectile. So now we can write some terms which is related to projectile motion. So the first one is maximum height. Maximum height is the maximum vertical displacement of the projectile. So you guys can consider a projectile motion like this. So we are throwing something from here. So we are applying a velocity in this particular direction. It has both horizontal component and vertical component. So it will follow a parabolic path and it is known as trajectory. That is what we just said. Now the maximum vertical displacement of the projectile is known as its maximum height. It's known as the maximum height. So the next term is time of flight. Time of flight. So whenever we are discussing about time of flight, how much time it is, how much time a projectile spent in air, which is known as time of flight. Usually we represent time of flight using the letter capital T. Okay. So then the term which is related to projectile motion is range or horizontal range. Sometimes we specifically write it as horizontal range, and some other time we will write it as range. Range is the maximum horizontal displacement or the maximum horizontal distance which is covered by the projectile. This is known as horizontal range. So these are the three main terms which is related to the projectile motion. Now we are going to write some equations for maximum height, time of flight and range of a horizontally launched projectile. So this is not a horizontally launched projectile. So we are throwing the projectile in a particular direction and the velocity component is in this particular direction, and we are resolving the velocity component into horizontal and the vertical. Horizontally launched projectile means you can consider like this. You have a table right here. So from the surface of the table, you are pushing something down. Then the parabolic path followed will be like this. This is known as horizontally launched projectile. So the example that we are discussed earlier, you guys are kicking a ball from the top of a mountain. So here also the path followed by the ball will be like this. So this is known as horizontally launched projectile. So horizontally launched projectile. So here the vertical component of velocity initially was equal to 0. Once we kick the ball, then the acceleration due to gravity comes to play. Then there will be a vertical component in the downward direction. So here we are going to write an equation for maximum height. So you guys know the equations of motion. So the equation for displacement is S is equal to ut plus half at square. So here we are going to find the maximum height. So this is something related to the vertical component. Then you don't have to consider the horizontal component. So u is actually the initial velocity of the vertical component. So initially there is no vertical component. Then you can vertical component of velocity. Okay. So there is no vertical component of velocity. So you can take u equal to 0. Then the first term will become equal to 0. Then half at square. So we know that here instead of t we can use time of flight. Time of flight is the time at which the projectile remains in the air. So we have to consider that particular time right here. So next term is acceleration due to gravity. So acceleration due to gravity this is actually acceleration. So we have to consider acceleration due to gravity because the only acceleration right here is acceleration due to gravity, the pulling down. So here you guys can write instead of a, you can write g. So you will get the equation. So instead of s we can write h, height. So height is equal to ut. This term will become equal to 0 as half g t square. T is time of flight. So you can write half g t square. This will be the equation for maximum height. Now you guys can try to find an equation for time of flight, which is easy because you can just rearrange the equation and then you can find an equation for time of flight. So here you can see 2 times h. This is 2 times h over g is equal to t square. So t is equal to root of th 2h over g. 2h over g. This will be the equation for time of flight. Next thing is range of the projectile. Range of projectile. So the range of projectile, we say that the maximum horizontal displacement of the projectile is known as the range of the projectile. Maximum horizontal displacement. So you guys know that velocity is equal to displacement over time. We all are familiar with the equation. So then the displacement will be equal to velocity times time. So here the horizontal displacement, maximum horizontal displacement is known as range of a projectile. So we can write horizontal component of velocity times time of flight. Here instead of time you guys can write time of flight. It will give you the value of range or the maximum horizontal displacement. So horizontal velocity times time of flight will give you the value of range or maximum horizontal displacement. So this will be the equation for range. Now we have to form an equation for the resultant velocity. So you guys know the velocities are acting perpendicular to each other, normal to each other, horizontal component and vertical component. The angle between them is equal to 90 degree. So this will be the vertical component and this is the horizontal component. The angle between them is equal to 90 degree. This is how it acts. This is a horizontal component and this is the vertical component. Vertical component is in the downward direction because it is due to acceleration due to gravity. So whenever we are finding the resultant velocity, then we can get, you guys know the equation for the resultant. So if we have two vectors, A vector and B vector, then the resultant velocity equation will be equal to root of A square plus B square plus 2AB cos theta. This will be the equation. So here you guys know we have two vectors. One is horizontal component of velocity, then other is vertical component of velocity, and we can write root of VH square plus VV square plus 2 VH into V cos theta. Theta is equal to 90 degree. When cos theta become equal to 90 degree, then the entire angle will, theta when is equal to 90 degree, then cos 90 will become equal to 0. The entire term will become equal to 0. So we can write VH square, horizontal component square plus V square, vertical component square plus 2 times VH into VV cos 90. The entire term will become equal to 0. So then the resultant velocity will be equal to VH square plus VV square. This will be the resultant velocity equation. The resultant velocity will be equal to VH square plus VV square. So these are the equations which is related to projectile motion.